Now in a trigonometry, there are two important rules, sine rule and cosine rule. These rules represent properties of triangle. Say here sine rule is, in any triangle, sides are proportional to the sine value, sines of the opposite angles. Means, say, in this triangle ABC, these are angles. Side opposite to angle A, we denote by small a. Side opposite to angle B, we denote by small b. And side opposite to angle C, we denote by small c. So these are the standard symbols for angles and sides when we discuss property of triangle. So in this triangle, sine value of angle A upon opposite side equal to sine value of angle B upon opposite side equal to sine value of angle C upon its opposite side. So here in denominator we keep opposite sides and in numerator we keep sine value of angle of triangle. So here in any triangle, sides are proportional to the sines of the opposite angles. So that means ratio is constant. Sine A upon small a equal to sine B upon small b equal to sine C upon small c. So it is sine rule. So remember this property. Now cosine rule. For the same triangle ABC, these are sides. Cosine value of A, cosine of this angle A is b square plus c square minus a square upon 2bc. See, cosine of A, how to remember this formula? B square plus c square means the sum of square of adjacent sides. These are adjacent sides. Angle A is between B and C. So these are adjacent sides. So cosine A is sum of square of adjacent sides minus square of opposite side upon 2 into adjacent sides, B into C, product of adjacent sides. Similarly, cosine value of B is a square plus c square minus opposite square b square upon 2 into product of adjacent sides, 2 into AC. Cosine C is sum of square of adjacent sides, say a square plus b square minus square of opposite side minus small c square upon 2 into product of adjacent sides, 2 into AB. So this is cosine rule. So these two properties are important. Now let us solve questions based on this rule. First question is, if values of sides of triangle are given, then we can find sine value or cosine value. Say here in triangle ABC, A is equal to 18, B is 24, C is 30. Then we are asked to find cos A, cos B, cos C, sine A, sine B and sine C. Values are given. Length of sides are given. A is 18, B is 24, C is 30. In triangle ABC, this is A, B, C. Angle C, we use capital C. Side opposite to angle A is small a. Its value is 18. Side opposite to angle B is small b. Its value is 24. Side opposite to angle C is small c. Its value is 30. Now we want to find this cosine and sine values of angles. So cosine A is, because we are given this small ABC, so putting value in this formula, cosine A is b square plus c square minus a square upon 2 into BC. That is b square plus c square. B square is 24 square, c square is 30 square, minus a square is 18 square upon 2 into b into c. So we substitute values. 24 square is 576 plus 300 square, 30 square is 900 minus 18 square, that is 324 upon, see 18 square, 18 into 18, 180, 144, so it is 324, it's okay. This is 324 upon 2 into 24 into 30. Now 900 plus 576, that is 1476. 9 plus 5, 14. 1476 minus 324. So 6 minus 4 is 2, 7 minus 2 is 5, 4 minus 3 is 1. So this is 1152. 1152 upon 2 into 24 into 30. Now simplifying this value here, this is equal to, say here divisible by 2, so 2 into 5, it is 10, 1 is left, 2 into 7, 14, 1 is left, 2 into 6, 12. Then here 24 into 24 is 576. Then 24 by 30, that is 6 into 4, 4 into 6, 24 upon 5 into 6, 30. So cosine A is 4 by 5. Therefore cosine A is equal to 4 by 5. And from cosine A we can calculate sine A. So sine A is, so to find sine A we use sine square A is 1 minus cos square A. So using identity to find value of sine from cosine, this is 1 minus 16 by 25. So 25 minus 16, 9 by 25. So sine A is 3 by 5. Sine square A is 9 by 25. So sine A, it can be plus or minus. But here there will be plus sign, because this is angle of triangle. A is angle of triangle and its value will be between 0 to 180. So this will be positive. Here I am putting reason, because value of A will be, because it's a value of a triangle, it will be from 0 to 180. And in first and second quadrant, sine is positive. That's why we don't take here negative value. Cosine can be negative, not sine. Let us find cos B. Now, so this was cosine A. Now cos B. Cos B is A square plus C square minus B square upon 2AC. A square plus C square. A square is 18 square is 324 plus c square is 900 minus b square is 576 upon 2 into a is 18, c is 30. Here it was 2bc, b was 24 and a was 2bc, c was 30. Okay, so this is 1224. It is 1224. 9 plus 3 12. 1224 minus 576 upon 2 into 18 into 30. Now 1224 minus 576, that is here 8 1 11 minus 7 4, here again 1 11 minus 5 6 0, 8 plus 6 14, 4 plus 1 8 plus 4 12, 12 plus 1 6 6 12, 12 1 0. It's okay, 648. So 648 is left. 2 into 18 into 30. Now simplifying this ratio, here this is 2 into 3 6, 324 into 2 648. Now 18 square is 324, 18 into 18 is 324. So this will be 3 into 6, 3 6 are 18, 5 6 are 30. So this is 3 by 5. Cos b is 3 by 5. Say this can be negative. It can be negative. Here cos a is positive, cos b is positive. If you find cos c using this formula, a square plus b square, a square 324, 576, I think cos c can be negative. So cos b 3 by 5, therefore sin b is, it is equal to 1 minus cos square b, it is equal to 1 minus 9 by 25, so 16 by 25. So b, sin b is equal to plus or minus, but because b is angle of triangle, it cannot be negative. So this is 4 by 5, because value of b, it is between 0 and 180, or we can say between 0 to pi. So this is sin b. Now we find cos c. So similarly, if you find cos c, say here in short I am showing cos c. Cos c is, I am writing here third step in very short. Similarly, cos c is, this is the formula, a square plus b square. A square is 324 plus b square is 576 minus c square 900 upon 2 into a into b. So this is equal to, here 5 plus 3 8, 8 plus 9, okay, it is 900, 900 minus 900 is 0, cos c is 0, cos c is 0, cos c is 0, so sin c, therefore sin c it will be 1, because sin square plus cos square c is 1, so sin c is, it will be 1. When cosine is 0, sine is plus 1, because of angle of triangle, it cannot be negative. Sine is always positive. Cosine can be negative, not sine. So this is application of this cosine rule. Using this formula, we can calculate cosine value and sine values if sides are given. Now application of this sine rule and cosine rule in this type of problems. Prove these results using these properties. These are properties of triangle. So say here we are beginning from left hand side. Left hand side is, see, this prove that type problems, whatever properties are given, These are for triangle. So I am adding here one word. Question: for triangle ABC, prove that for triangle ABC. Similarly, this is also for triangle ABC. These are properties of triangle. So beginning from left hand side is A plus B upon C. Now here, this is A plus B by C. RHS is cos of A minus B by 2 upon sine C by 2. Here I am using sine rule. Sine rule in this form: A upon sine A equal to B upon sine B equal to C upon sine C. So before putting values, let me take this statement. Here we know that A upon sine A equal to B upon sine B equal to C upon sine C. This is sine rule. This can be used in this form as well as in this form. Meaning is same. Suppose that this ratio is equal to K. We say this ratio is equal to K. Therefore, E is equal to K into sine A, B is equal to K into sine B, C is equal to K into sine C. Putting these values in left hand side will be equal to, left hand side is A plus B by C. Now A is K into sine A, B is K into sine B, and C is K into sine C. Taking K common, K will be cancelled. So it is sine A plus sine B upon sine C. Now using formula, sine A plus sine B is 2 times sine A plus B by 2 cos A minus B by 2 upon sine C. Now look here. See, in the right hand side, this is cos of A minus B by 2. Cos of A minus B by 2. This is required. That means this will be cancelled. Sine of A plus B by 2 will be cancelled. So it is possible if denominator we convert in terms of A plus B by 2 or in terms of A and B. So here first of all what I do, here this C I replace by C is pi minus A plus B, because A plus B plus C is pi. These are properties of triangle. A plus B plus C, it is equal to pi. So C is equal to pi minus A plus B. So using this basic property as well as this sine rule. So now this will be equal to, this is equal to 2 times sine of A plus B by 2 cos of A minus B by 2 upon, now sine pi minus theta, sine pi minus theta is sine theta, sine of pi minus theta is sine theta. Now here we convert this in theta by 2. So if this is alpha, then sine alpha is 2 sine alpha by 2 cos alpha by 2. So applying here formula, sine alpha is 2 sine alpha by 2 cos alpha by 2, this part will be cancelled. So 2 into sine a plus b by 2 cos a minus b by 2 upon. Now sine alpha is 2 sine alpha by 2 cos alpha by 2. Sine alpha 2 sine alpha by 2 cos alpha by 2. So see, this is cancelled. So what is left? We have cos of a minus b by 2 upon. Now see, numerator is obtained, but in denominator we need sine c by 2. So this left number we should convert in terms of c. So what we do to convert in terms of c? Again here I replace a plus b by pi minus c. A plus b is pi minus c and divide by 2. So divide individually. So this is cos of a minus b by 2 upon sine c by 2. Cos pi by 2 minus theta. Cos pi by 2 minus theta is sine theta. So this is sine c by 2. So this is RHS. So LHS is equal to RHS. Result is proved. Now in this question, here we want to prove sine of b minus c by 2 is equal to b minus c upon a into cos of a by 2. Here I am beginning from RHS. RHS is b minus c by a into cos of a by 2. Here we will use sine rule by this method. So again, in this question also we know that a upon sine a equal to b upon sine b equal to c upon sine c, and suppose this is equal to k. So a is k into sine a, b is k into sine b, c is k into sine c. Now putting in this left hand side, b is k into sine b minus c is k into sine c. This is small c, this is capital C, upon a is k into sine a into cos of a by 2. Now here k will be cancelled. So sine b minus sine c upon sine a into cos of a by 2. We are going to derive LHS. Beginning from RHS, we are working on RHS and going to derive LHS. Now sine b minus sine c is 2 cos b plus c by 2 sine b minus c by 2 upon this sine a I am putting as 2 sine a by 2 into cos a by 2, because if I put here 2 sine a by 2 into cos a by 2, then this cos a by 2 which is given, this will be cancelled. Now see, this 2 is also cancelled. Here we require only sine of b minus c by 2. It means these terms will also be cancelled. Here this is b plus c by 2, here it is a by 2. So this will be cancelled if they have same value, they are ditto. So what we do, again we use this property, a plus b plus c is pi, a plus b plus c equal to pi. So what I do, I put here pi minus a So this is equal to, it is equal to cos of pi minus a. B plus c is pi minus a. Divide by 2. So divide by 2 individually into sine of b minus c by 2 upon sine a by 2. And now this is cos pi by 2 minus theta. Cos pi by 2 minus theta is sine theta into sine of b minus c by 2 upon sine a by 2. This is cancelled. So it is LHS. So LHS is equal to RHS. So result is proved. For triangle ABC, prove that A into B cosine C minus C into cos B, it is equal to B square minus C square. Say here, beginning from left hand side, A into B cosine C minus C cosine B. Now see, RHS is B square minus C square, and we know that cosine formula contains squares and RHS is free from cosine or sine. It is B square minus C square. So what we do here, using cosine rule, A into B into cosine C is A square plus B square minus C square upon 2AB minus C into cosine B is A square plus C square minus B square upon 2A into C. Close the bracket. So in this question we are using cosine rule. So this is equal to, now see, AB divided by AB, this will be cancelled. So what is left here? A square plus B square minus C square upon 2 minus, see, A into C is cancelled. What is left here? A square plus C square minus B square upon 2. This is left. So that is, here 2 is LCM. A square plus B square minus C square minus A square minus C square plus B square. So here A square is cancelled. 2 times B square minus C square upon 2. So this is B square minus C square. It is RHS. So LHS is equal to RHS. Now this side. For triangle ABC, prove that B plus C into cos of B plus C by 2, it is equal to A into cos of B minus C by 2. Beginning from left hand side, B plus C into cos of B plus C by 2. So here RHS is free from small b and small c. So it is necessary to remove the small b and small c. So we use sine rule. We know that b upon sine b is equal to c upon sine c. Suppose it is equal to k. So b will be equal to k sine b. So here k sine b plus k sine c into cos of b plus c by 2. So reason for this step we put here in front of this step. So here this is the reason, because b by sine b is equal to c by sine c equal to k is used. Now k is common. So sine b plus sine c into cos of b plus c by 2. Now here formula sine b plus sine c, it is 2 into sine of b plus c by 2 into cos of b minus c by 2 into cos of b plus c by 2. Sin b plus sin c, 2 sin b plus c by 2 cos b minus c by 2, and this number we keep as it is. Now see, observe RHS. RHS is a into cos b minus c by 2. So this product cos b minus c by 2 is visible, which is a part of requirement. So now do not disturb this number. So keep this inside. So this number I am keeping inside. So k into 2 times sine of b plus c by 2 into cos of b plus c by 2. This we are taking in second place, and this number I am keeping inside. We don't want to disturb cos of b minus c by 2. Whatever required term is obtained, derived, keep inside. So now due work is only in this part. Now value of this part will be equal to a. This will be equal to a. So trying to prove that this is equal to a. Now look here. This is k into. Now 2 sin theta cos theta. See, this number is same. 2 times sin theta cos theta. It is sine of double theta. So it is sine of b plus c. This number as it is cos of b minus c by 2. Now k into b plus c, it is pi minus a. b plus c is pi minus a into cos of b minus c by 2. So this is k into sine of pi minus a is sine a cos b minus c by 2. Now k into sine a is small a. Say here, we can join here ratio, because a upon sine a equal to b upon sine b equal to c upon sine c is k. So k into sine a is small a. K into sine a, it is small a into cos of b minus c by 2, and it is RHS. This is equal to RHS. So LHS equal to RHS. For any triangle, prove that a into cos a plus b into cos b plus c into cos c is 2a sin b into sin c. This is for any triangle ABC. Say beginning from left hand side. Here left hand side is a into cos a, b into cos b, c into cos c. In the first step, we use a sine rule. So here we replace small a, small b, small c by k into sine a, cos a as it is. This is k into sine b, cos b as it is. This is k into sine c, cos c as it is. And the reason for this step is a upon sine a equal to b upon sine b equal to c upon sine c equal to k. Now with the next step. So here this is sine a into cos a, this is sine b into cos b, this is sine c into cos c. We divide by 2, multiply by 2, and taking k common. K is common, divide by 2. Inside multiply by 2. So 2 sine a cos a plus 2 sine b cos b plus 2 sine c cos c. So that is k by 2. Now 2 sine a into cos a is sine 2a. 2 sine b into cos b, sine 2b. And this term just we keep as it is. This number we are keeping as it is. We will continue work on first two numbers. We are keeping this as it is because look here. We want sine c common. So because this last term contains sin c, we shall create sin c as a factor in this part. So sin c, it will be common. So out of these three numbers, keep any one term as it is. Either keep this number as it is or keep this number as it is. If you keep this number as it is, you will be able to take sin b common at last. If you keep this term as it is, at last sin a will be common. So now we are keeping this number as it is. If you put here sin 2c, then again to come on track, you have to replace sin 2c by again 2 sin c cos c. So at present we keep this as it is. Now k by 2. Now here sin c plus sin d, it is 2 sin c plus d by 2, that is a plus b, cos c minus d by 2, that is a minus b, plus 2 times sin c into cos c. Our target is to take sin c common. That's why we kept this last term as it is. Here it is sin c. And see here sin c is visible. Sine of a plus b, see, sine of a plus b, it is sine of pi minus c, or we can say 180 minus c. So it is sin c. So I replace this number by sin c. So k by 2 into 2 sin c into cos of a minus b plus 2 sin c, and with that this number cos c, we are also replacing cos c by cos of pi minus a plus b. C is pi minus a plus b, that is cos pi minus theta is minus cos theta. Cos pi minus theta is minus cos theta. So cos c, I put its value, it is minus cos a plus b. And here this is the reason for this last expression. So this number we are converting in terms of c, this number we convert in terms of a plus b. Because when we convert this number in terms of c, this sin c, it will be common, and we need only one time c. Besides sin c, nowhere here c is given. So that's why after taking sin c common, we don't need any number in terms of c. That's why this number we have converted in a and b. So next step, 2 sin c common. So k by 2 into 2 sin c common into bracket cos of a minus b minus cos of a plus b. This 2 is cancelled. So k into sin c into, now this is cos d minus cos c. So we know that cos d minus cos c is 2 sin c plus d by 2 sin c minus d by 2. So in the next step we use this result. Cos d minus cos c is 2 sin c plus d by 2 sin c minus d by 2. So 2 sin, this is our c, this is d. So 2 sin c plus d, c plus d is 2a. So 2a by 2 sin c minus d. So difference of this number is 2b by 2. So reason for this step, it is shown here. This is the reason for this step. That is, k into sine c into 2 sine a into sine b. Now here 2 I am taking out, then k as it is, then sine a into sine b into sine c. Now k sine a, see k sine a is a, so this is a into sine b into sine c, so this is RHS. So LHS is equal to RHS. In this question, for triangle ABC, prove that this is equal to 0. Say beginning from left hand side, b square minus c square into cot A plus c square minus a square into cot B plus a square minus b square into cot C. Now first of all, here cot we express as cos A by sin A plus c square minus a square cot B cos B by sin B plus a square minus b square cot C is cos C by sin C. Now we are using sine rule and cosine rule both. So say b square minus c square into, now cos A is b square plus c square minus a square upon 2bc. Cos A is b square plus c square minus a square upon 2bc. Now sin A, this is in denominator, I am putting here value of sin A. Sin A is k into A. See how it is k into A. See here we are using A upon sin A. Sin A upon A equal to sin B upon B equal to sin C upon C. This is sine rule. Suppose that this is equal to k. So sin A is k into A. So in this way sine rule is used. Plus c square minus a square into, now cos B by sin B, cos B is a square plus c square minus b square upon 2ac, and sin B is denominator, so sin B I am putting as k into B plus, now here see I need space, so removing this step, cos C is, this is a square minus b square into cos C is a square plus b square minus c square upon 2ab, and sin C is, it is k into C. So this is from sine rule and cosine rule, because sin A upon A is sin B upon B is sin C upon C equal to k. This rule is used and cosine rule is used. So this is equal to, now here observe denominator. In the denominator you can see that 2 times k ABC, 2 times k ABC, 2 times k ABC common. So 2 times k ABC common. In bracket this is left b square minus c square into b square plus c square minus a square plus c square minus a square, c square plus a square minus b square plus a square minus b square, a square plus b square minus c square. Now expanding this, see here I am multiplying this bunch with this b square plus c square. So b square minus c square into b square plus c square is b raised to 4 minus c raised to 4. Now this bunch I am multiplying with minus a square. So b square into minus a square is minus a square b square, then minus minus plus a square c square. Similarly, c square minus a square into c square plus a square is c raised to 4 minus a raised to 4. And multiplying this with minus b square. So minus b square c square plus a square b square. Similarly here, multiplying this bunch with a square plus b square. So it is a raised to 4 minus b raised to 4, and with this number minus c square a square plus b square c square. So that is expansion. Now you can see that this plus b raised to 4 minus b raised to 4 minus c raised to 4 plus c raised to 4, then minus a raised to 4 plus a raised to 4 plus a square b square minus a square b square plus a square c square minus a square c square minus b square c square plus b square c square, everything is cancelled. So 1 upon 2k ABC into 0, this is 0. So it is RHS. So LHS is equal to RHS. So result is proved.